Hello, this is Mike at GameFromScratch, and welcome back to another episode in the Closer Look at Game Engine series. Today we're going to be taking a look at SFML, which coincidentally gets a lot harder to say as you say it over and over again, so get ready for me to be quite tongue-tied through this entire video. But anyways, first off, let me start by saying SFML is not a game engine. It, however, provides a lot of the functionality that a game engine would work with, and you could quite easily build a game engine on top of it. What SFML is, in fact, is a cross-platform C++-based library for providing multimedia functions. Basically, it provides a cross-platform implementation of window creation, 2D graphics, input handling, including mouse, keyboard, touch, accelerometer, and gamepad support. As well as implementing basic network functionality, both UDP and TCP sockets, as well as a reference implementation of FTP and HTTP, as well as, and I am missing something, oh yes, audio support, including sound playback and music streaming support. So pretty much a lot of the things that you would traditionally expect a game engine to do, SFML provides that functionality. It is not, however, as I said, a game engine because there is no scene graph, there's no level editors, there's no tools whatsoever. This is an entirely code-focused set of libraries. So this example itself is actually going to be, this video is going to cover a lot of coding, configuration, and setup stuff. If you're already experienced with C++, you can skip ahead over a lot of at least the initial stuff, or you can go to the text-based version of this review. For each closer look at, I do both a video and a text-based post. The text-based post covers pretty much exactly the same material, has all of the code samples we're about to discuss. Now, one of the very nice things about SFML, like I said, hard to say, is that it provides this support in a modular format. There is a base library system that everything depends on, so that one needs to be included. And on top of that, you have a library so-called window, which includes obviously window creation and handling code. It also has the input logic in there as well. There's also a library for audio, a library for networking, and a library for graphics. So if you want to use one of those things individually, you can. You can just link to, say, the networking and the system module and nothing else. Another very common use for SFML is for people doing 3D OpenGL development. One of the big things missing from OpenGL is window creation and input handling. So you can actually use, say, system and window libraries on top of OpenGL and use it for creating your window, handling the input, etc. Again, a very common approach for people that don't want to use an existing tool like Glut, for example. Another thing that I kind of touched on right there that's very key and important to point out is SFML is not in any way whatsoever, nor will it ever be, according to the authors, a 3D library. It's beyond the scope of what it's trying to do. It is not about that. Basically, there's all kinds of things in that space already handling that. So if you're here looking for 3D, this is not the library for you. That is not the functionality it tries to provide, so move on. Anyways, it is open source based. I believe it's based on the zlib library, which is a very liberal library. The source code is available on GitHub. As I mentioned earlier, it is a C++ based library. However, if we head on over here to the downloads page, you'll see there are several sets of bindings available. And as I write this, I believe SFML 2.3.2 was just released. And you'll notice here some of the bindings, including the official bindings. These two are the only official bindings, the C and the .NET based libraries. And even the .NET one is slightly out of, it's outdated basically. And some of these are a little bit more so. But you have a number of bindings being provided by the community for just about every language you could think to use. Especially if your language itself doesn't support C bindings or it's inconvenient to bind to C. So you don't have to be working in C++ to get the most out of SFML. However, the documentation and all the examples are written for C++ usage. So probably the best way to actually show you SFML is to show you it in action. And when we get started, we just go ahead and download it. Now, here's one of those things. If you are a newish or completely new C++ developer, this is C++'s Achilles heel, or at least one of them. The build system is antiquated. It's based on the C system from like the 1970s, so the linking process in C++ stinks. It's an unpleasant experience, and it creates a great deal of complications, especially for someone just starting out. I'm going to show you very quickly in this library how to set up and use SFML with Visual Studio 2013. Obviously, if you are working on Mac in Xcode, or you're using something like the MingW compiler, etc., your process is going to be a little bit different. But there is a fair bit of configuration you have to do to get a game up and going. And on top of that, your linker options are various and extensive. And as you'll see in a second, we go to the download here. So here are the Windows-only versions. And you'll see there's a set of downloads not only for each compiler available, so MingW, Visual Studio, etc. There's also subversions for each different version. So Visual Studio 2010, 2012, and 2013, and then also 2015, all have different binary formats. So a library generated in one version can't be used with a library from another version. So you have to do a recompile. On top, 32 and 64-bit are very much separate things. We're moving to a 64-bit world, but as of right now, it's still a little easier on Windows to stick with the 32-bit toolchain. So you have to get the library binaries to match the actual version of the compiler you're going to be working with. A little bit easier on Mac OS, and in Linux world, there's actually some complications in Linux as well, where you have ELF binaries versus other format binaries. But if this is more definitely, if you're working in Windows, the problem is a little bit more pronounced. And then when we get into actually dealing with the binaries, there's also several types of builds. There's a debug build versus a release build. A debug build has more information in it for debugging versions, but you need to link the right version there. And on top of that, there's also a dynamic or DLL-based or static, where all the library functionality is copied into your code. So you have 32 versus 64-bit for each individual compiler, which can be either static or dynamic, debug or release. So that does create a lot of possible mismatches. And even to make things a little bit more confusing at times, is SFML itself actually depends on a couple of other libraries, FreeType, PNG and zlib libraries, I believe, and a couple other ones. They have to also be built with the same version and same format. Now the nice thing is, and the underlying point of this, is the project file that's SFML source code. So if you go to GitHub and download the source code, it's actually a CMake-based project system. CMake is sort of, you can think of it as a makefile maker. So you run up CMake, you load it, and you say, I want to build this project for Visual Studio 2013, and it'll generate you the proper project files or makefile to work with from there. So if you are building it from source, the CMake functionality does make that a nice way to go. In this particular case, I'm going to go with, as I said, 2013 32-bit version right here. I've already downloaded it, so I'm not going to do that again. But grab whichever version you're going to work with. The process inside of Visual Studio should be almost identical. Now, one of the things that I was going to go ahead and use 2015. Microsoft have done some weird things to the standard C libraries in their newest version of the compiler. So I'm going to stay away from it right now, because it has created some headaches with other C++ projects that I've gone to work with. So I'm going to go with the tried, tested, and true Visual Studio 2013. Coincidentally, this is available in a community version, which is a full version, completely free, so long as you make less than a couple $1,000,000 and have less than 5 developers or something to that effect. So if you don't already have it, go ahead and download it. And this is what we're going to use. And when you download it, it comes in as, let me see, where's my downloads? Here we go. It's just a zip file, and we're going to take and we're going to open up that zip file, which I've already done, and we need a couple of the files inside of here. There's a few ways you can go about this. You can put the lib files in like a common lib folder. You can move them into your project, which is what I'm going to do. There's a couple different approaches you can take. Same with the DLLs. The DLLs, if you do not compile statically, that is, if the DLL's contents aren't copied into your executable, the DLLs need to be in one of 4 locations. And I believe the search order on Windows at least goes the same folder as your executable. Let's see, executable folder, system path, system directory, and I'm missing one. But that's the search order it goes. So if you dump all the SFML libraries into C:/Windows/System32, it'll work, but I probably wouldn't recommend doing that, especially when you start getting into version mismatches and such, or you start upgrading versions. So I would recommend setting up somewhat like I'm about to in this project. So first things first, let's go ahead and fire up Visual Studio. Now, you're going to notice there's a lot of existing SFML code. I've actually already done this video twice, and it's screwed up twice. So this is my third run through it. If Camtasia screws up again, I'm going to have a riot here. But let's go ahead and create this all over again. Your option when working with SFML from Visual Studio anyways is you can either create a console application or a Windows application, or somewhat confusingly, a Windows console application, which is what we're going to start with. We're going to start with a Win32 console application here. And let's call this SFML demo 2, because I've already done it a couple times. And we don't want to create a directory. Yes, we do. All right. Next up, now here's where your options come in. You can have it create a console app and then create your window. This means your typical DOS or terminal window will show up and then another window will be created. This approach works fine, especially if you want to have debugging information being printed, so you're doing console out, cout type debugging, then that console window can actually prove quite handy. However, if you want to not have that window there, if you find it aesthetically unpleasing, you can actually create this as a window app. But we're going to have to include an additional lib file, which is a stub providing the WinMain for us. And that's the approach I'll take here. If you take the console app approach, you do not have to do this additional link, and I'll show it when we get to it. I'll do an empty project. I don't actually know what that does, so we'll turn that off and create. All right, so we are in an initial completely empty Visual Studio file right now, and we're going to have to set up the include path and the linker path. And what I'm going to do now is go back to that download we created earlier, right here. I'm going to just change this name out slightly. Let's get rid of the versioning information, and we'll just copy that. And it's into temp, SFML demo 2, and so there's our solution folder. Here's our project folder. Inside of our project, we'll dump it there. All right, so if you look inside of this folder quickly, you'll see the biggest thing we need. We'll actually get rid of everything we don't. We're not building it. We're not using documentation, and we're not using the examples. Keep the licenses, probably legally required, but the big files we need are lib, include, and bin. Bin is where your DLLs exist, include is where your include files are, and lib is where your library files are. Pretty self-explanatory. So now we need to configure Visual Studio to use all of these things. Right-click on your project here and click Properties. And we have a few settings we have to set. First, we're not setting it right now, but an important thing to be aware of is this working directory. This is where, when you load a file later on, it will be relative to this point. So make sure that when you have assets available, for example, a font or an image file, or etc., this is where you put them, or some path below that one. But what we need to configure first off is C++, and it's here, and we want to do additional include directories right there. So we're going to tell it basically where our #include files are. Add a new one, and here I'll do it the lazy way. It's in SFML include. So, you know what? That's ugly, because if I move it later, that path won't work. So let's do this as project directory, like so. So that's saying our include files, when you're searching for #included files, also look at this directory, like so. And we need to do the same thing in our linker. Additional library directories right here, edit, add a new one, paste, and it's lib instead. All right, now there's a little bit more setup to actually have to do now on the library side of things, and that is we have to tell it which lib files we want to be using here. There's a little bit of complication here, and first let me talk about one thing, and that is static versus dynamic. So are you going to ship DLLs with your game, or are you going to have it all kind of compiled and schmucked together into your executable? And which one you pick determines which libs you're now going to link to. And if I go here and I show you in the lib folder, you'll see we have a bunch of different versions. We have I'll use the audio libraries, for example, these four right here. You have SFML audio, audio-D, audio-S, audio-S-D. Now what that is audio is your dynamic version. That's your DLL version. And that library is pretty much just like a table of contents or a quick link reference to where certain functions and functionality is supported inside of the DLL. It's sort of, you can think of it as a stub. And that's what is resultant. You can see the file size here. So this little quick table of reference is only 54K in size, whereas the full version static is 1.5 meg, while the full version debug is 4 meg. And that's a direct result on the size. When you do static, those libraries are copied directly into your resulting executable. So if you use a single function from SFML audio static debug version, your executable is going to grow by this much. Which approach you take is completely up to you. There's advantages one way or the other. In a lot of ways, actually doing a static build is probably easier to maintain. You don't run into DLL mismatches, versioning information, etc. And it creates a single executable as a result. However, your configuration process is a lot more of a pain in the ass. And I'm going to go with dynamic just specifically to get away from that. But the thing to be aware of here then, you got to pick which library you want to link to. So we're going to build in debug version, our debug build, as you see up here. So we're going to want one of these -Ds. And since we're using the dynamic as opposed to the static, we want this guy right here. So we want to link in each of these guys in turn. Now the catch is also, there are dependencies on other libraries. As I mentioned earlier, at the very, very core, system is required. This guy has to be there for all of the rest of them to work. They all depend on functionality provided by system. And when you add libraries to Visual Studio, the order you add them in is important. So the most dependent upon, or the lowest level, the keyest libraries go on the right, where the least dependent upon go on the left. So we're going to go in here now and add these libraries in. I wish I could easily keep this on screen here. Let me do something quick. There. Now I have easy access to both. So properties here, I'm going to link them all in because I'm just being that way. But basically, you just have to link into the functionality you need. And it is in, let me think, it's under linker, under input. And right here you see additional dependencies. And here's all of the Windows 32 libraries that are being included. And we're going to depend on a lot of these, so we want to be to the left of them. So right here. Now, as I mentioned earlier on too, when we were building, we had a choice between a console and a window app. I said there was a library that we had to link to in that case. That library is called SFML-main. So it depends on everything else. So let's go SFML main first. There's no static or debug version of that. All it really is WinMain. It's a stub for an entry point, nothing else. And now we're going to add the other libraries we depend on. So SFML, audio, dash D, lib, SFML graphics, dash D, lib, SFML network, which we're not going to use at all in this demo, but since I'm here, SFML systems last, window -d .lib, and then finally SFML system .lib. Oops, dash D. All right, so there we link to the debug dynamic build of all of those different libraries. I think that is it. We are now configured and up and running to go. The last thing that you might want to be aware of if you are building static, right here in preprocessor, you have to add SFML_static as a predefined macro. But if you do a static build, here's where it gets a lot more complicated and why I'm not doing it. As of 2.2 version of SFML, you now have to also link to all of the dependencies. And that's another 25-ish lib files, so it makes this line very, very long and a lot more complicated to write. So we'll just stick with that version for now. Hopefully I haven't made any errors. We'll come back and find out if I did. So now we just need to add a source code file here. Oh, not class. Here, let me just get back to full screen. Add item, C++, source sounds good. All right, so our empty project file is up and going. We are going to start with the barest of bones SFML application. Basically, we're just going to create a window, and that's about it. And that includes, pound includes. So first off, we're going to find out if, see, it found it, so we're good there. Oh, that's annoying. So that's going to mismatch my code slightly because I used a different, yeah, that's annoying. Anyways, I put it in a different path the last time I did this, so my header files are resolving out to a different directory than I actually would usually use. It's normally just this. See if it gets by with that. No, it's not going to like that. All right, 1 second. This is interesting. For some reason, none of my settings saved. So let's do it again. So edit, add new. So maybe I did my macro wrong. Let me just make sure it's right. So I'll assign project SFML / include. Enter. Okay. All right, so that seems to be set. Let's copy that sucker. Go back over to the linker. I probably didn't click apply, or I don't know what just happened, to be honest. All right. There. There. Okay, so it seems to be set up right. And okay, now we don't have any errors here. So sorry about that. I probably didn't hit apply. So our main entry point. And the beginning of our program. So first off, we want to go ahead and create a window that is going to display everything. So basically the heart of our program, and it's something called a render window. And let's just call it render window. And we pass in a video mode. Now you'll notice I'm not using using namespace SFML. I could, be a lot less typing. I don't know why I do this to myself. So the SF namespace obviously can be used. And just pass in the window title. I can't type today. There we go. So that creates a window with the dimensions of 640 by 480 with the title Hello Cruel World. Now that we have our window, we need to basically create our game loop. First, our loop is just going to run until the window is closed. And that is a while, and then render window.is open. So just loop forever and ever and ever and ever until the window is closed. And next up, we need to actually respond to that window closed event. And there's one of the nice things about SFML is there's a very nice built-in event system there. And that's what we're about to use. But we need to have another while loop in here that's actually going to check for events. Now you can actually have, while this window is running, multiple events could have possibly occurred. And it's basically a queue of events. So we're going to now say, give me all the events that happened since the last run through this loop. It's generally never going to be more than one, but it's possible. So first off, we need an event to actually store this in. Oh, actually, let's move this outside of the event. So don't want to obviously declare that inside of a while loop if we're going to be using it over and over and over and over again. So while render window dot, oops, I can't type today. Window dot poll event. So basically, what events occurred, and give me one. And this will return false when there are no more events. Otherwise, it will basically give you all of the events that are currently queued up in that window. Events are things like close window, mouse move, etc. And if the event dot type equals event type closed. Oh, here, let me go back and I'll show you some of the other event types. So joystick, keyboard, mouse, sensor, blah blah blah. But we're going with closed. So that is if the window was closed, we're going to handle that event. And all we're going to do is actually close the window. So game event, basically, here is your main loop. This is going to run until this occurs. So basically, over and over and over again, until you close your window, let's keep checking for more events. And if the event is closed, close, which will break out of this loop then and end our program. So let's end our event handling. So after all of the events from this current frame have been handled, now we want to clear our window and display it. So render window dot clear, and we're going to clear it to the color white. And next up, render window dot display. There you go. So this is your very first SFML application. Very straightforward, very simple. Now we just have to find out if it very works. Nope, I screwed something up. Can I start because, oh, I didn't, there we go. Remember that I told you need to have the DLLs in your executable path? Yeah, I need to follow my own advice. So let's go back here. Here's the SFML distro, bin, and we just need the -d version, the debug build versions. So -d, 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 and then the OpenAL, which is the audio libraries that SFML itself uses. And just go back to your debug folder, and let me just make sure I'm not doing this wrong. All right, so we'll paste that there. Let's try this again. All right, that is not my debug folder, obviously. Where is my executable being generated? Right there. God, I hate you. I do not like the default project setup layout of Visual Studio. But make sure you put it in the proper folder, which in this case is off of your solution folder in the debug folder. So here is your executable. This is going to be a little confusion. So this here, where the SLN file is, this is solution dir when it comes to macros. This here is project dir. And this here is confusing as hell versus here. So, yeah. It's a Visual Studioism. I should have configured it otherwise, but I didn't. So anyway, here you are running, up and going, your very first application. Congratulations. And now let's make it just do a little bit more. We're gonna ubiquitous first application is generally hello world, and let's stay with convention. Now, first things first, we're actually going to need a font file, a TTF file. If you're running Windows such as this, there should be one available. There's plenty available, actually, part of your system directory. So just go into your Windows folder and on the fonts directory, and you'll get a collection of them. And say here, I used that guy. Yeah. So we're just going to go ahead and grab the regular version, just copy that guy, and go back to your code folder, temp, and your working directory by default is set to your project directory unless you change it. So in that case, right here is where it's going to look for assets, and we'll just paste that calibri.ttf file in there. Now, big word of warning here, these TTF files that I just used, you have a license to use them locally on your own computer. They're shipped as part of Windows, etc. Font files are often copywritten and trademarked and etc. They're just like software for that matter, so you do need a license to distribute things. So you cannot ship a game using this file, for example. Now, there are dozens, hundreds, maybe even thousands of open source TTF files available on the web. So if you are going to make a full game, go ahead and use an actual legally licensed version. You can't just distribute this file like I'm using here. So just word to a wise, you can't do that. So now that we have our font, let's go ahead and use it. First things first, we create the font file. This is a resource file we're going to be loading with. This is a sort of heavyweight class. This will be doing the loading, the parsing, and the holding of the font data. So you don't want to do these, in a performance critical code, and this will take up a fair bit of memory. So be careful where you use these types of logic, same for SF texture, image, audio files, etc. So we just loaded the font. Now let's go ahead and, no, we just created a font. Now let's go ahead and load one. Sorry about that. I don't know how to turn that off in Windows 10, so enjoy my retweets. Just go font dot load from file. Now again, this path is set to your working directory, so everything is relative to that. So if you change that working directory path, debugging. If you change this guy, this is where it determines what the root of these kind of calls are. So we actually copied it into the root of our project. So calibri.ttf. So there, we're going to load our file. This will return a Boolean if it is successful or not. So in the case that it's not, let's do some incredibly good error handling here. And basically, we're just going to exit out with the error code 42. No particular reason. So there. Code didn't bomb out, so obviously that resource loaded just fine. So now that we have our font loaded, let's go ahead and create a text object. A text object is basically it's a positional object. It inherits from two classes, transformable and drawable. And the nice thing is you'll see consistency in SFML. A lot of classes inherit from these, including sprite, etc. So the way you work with the derived classes is very, very similar. So you will see when we go on with a further example how the code remains remarkably the same as what we're dealing with right now. So now that let's go ahead and create that text class. This text class is a lightweight class. It has a lot less information. The font information is referenced. It's not held in this class, so you can create these a lot faster. They take up a lot less memory. This is basically an instance of our font being used. Again, hello world, and let's make this one, so pass in our font, and we will create it as 64 point. So we just created hello world text. Let's set the color of our text to SF:color:, red, because red is a good color. All right, so very, very simple version. Now let's go ahead and draw that text. And that's just render window.draw text. Let's run this. And ta-da! Your very first hello world. Congratulations. A slightly more interesting example. Now let's take this one step further and actually position that guy in the center. Show you a little bit more of the functionality at play here. And that is back here before our loop. Now let's position it. First off, we're going to get the bounds of said text. And that is using an SF flow rect bounds text.get local bounds. So basically this is getting a rectangle on screen representing the pixel size of the font you've drawn and the position of it, which we will now use to center it, which will make sense in a second. So there we're getting the bounds. Next up, let's set the position. Set position. In order to do this, we need to get render window.get size, and then for some reason, instead of being width and height, unfortunately they are X and Y, which is not intuitive. So middle of the screen, and bounds.left plus bounds.width.2, middle of our text object. So that's the X position, and now we need our Y position, which is going to be render window.get size.y for height, and then bounds.top plus bounds.width, height to 2. That's it. So we now positioned it in the middle of the screen, ideally, assuming I did not make any mistakes, and let's run that. There you go. So we got text position in the center of the screen. Now there's something valuable to be seen here. OpenGL uses an origin system of 0, 0 being the bottom left corner, or here. In the case of SFML, however, it uses the top left corner, which I like. That's the way Windows works. So in Windows, right here is 0, 0, and here is width and height. Whereas in this case, locally, 0, 0, and width height. So when we draw a sprite element or a text element, its origin or its local drawing reference is also 0, 0 is its top left, so right here. Which is why when we position this guy, we used the calculation based off of both of their centers and took into account half of their width, half of their height to get that top left corner. Now, the key thing to be aware of also is you can change this using set origin if you would rather use it via the center, bottom left corner, whatever. So it can be configured. We're not going to do that in any of our examples today, however. So really, that is pretty complete, full example. Now let's move on, and I'll show you some of the consistency in SFML's implementation of things. And we're going to move on now to use and draw a texture and a sprite. A texture is to a sprite as a font is to a text. So the texture is the image file. Now that's going to raise an interesting question. If you go and look at the documentation, you'll see that there's an SF image and an SF texture, and you might be wondering, what is this difference? So what is the difference between an image and a texture? And there's really nothing. They're basically identical classes, but what is important is where they reside. And when you load an image, it's in the heap. It is in system memory. When you load a texture, it's on the video card. So when you draw an image, it needs to be copied to the video card to be displayed, whereas a texture is already there, which realistically turns into a very, very, very big difference in performance between the two. Obviously, generally anyways, video card memory is in a little bit more of a premium, so you don't want to do a texture if it doesn't need to be performant, but that is the difference between an image and a texture, is where they reside in memory. So that lesson given, let's strip this guy down so we no longer have a font, we no longer have a text, we no longer have positioning, no longer draw the font, and we're back to a stock window. Now let's go ahead and make this load a texture instead. And now we're going to need a texture. As you saw, we loaded the TTF file into the project directory, our working directory set. We're going to do the same thing, but instead we're going to bring in an image. And I like this image. Don't know why, it's just one I like. So we're going to go ahead and load it. So first off, very, very, very consistent in how this works. We're going to load a texture instead of a font. So texture, like so. And then now that we have our texture, we're going to load it from file. Now, once again, returns a Boolean if it fails. And it was called GFS logo.png. Most image type formats are supported. I don't actually remember which ones aren't off the top of my head. All right, so we're going to go ahead there. That will load our image file. Now, just going to make sure that we don't error out. Make sure I didn't have a pathing error. We do have an error. What did I do wrong? GFS logo.png. Oh, sorry. That would have errored every single time it worked. So yeah, it's good. That's why you go ahead and test before you get too far along. So now let's go ahead and load it. It found the file. It is loaded. So now that we have a loaded texture, let's go ahead and use it. And that is, once again, texture heavyweight class. Don't load them. Be careful with how you use them. A lot of memory consumed. Sprite lightweight class. Sprite's all about positioning and drawing. So sprite, and the sprite will use our texture. So we're going to go ahead and just pass texture into the constructor like so. So we just went ahead and created a sprite. And this is pretty much doing nothing because it should be the default, but we'll set the position to start with at the top left corner like so. And finally, we come back down here and render window, draw our sprite. Now let's run that. And ta-da! There, we just successfully drew an image file on screen. Very, very simple, very, very nice, very, very easy. Now let's look quickly at dealing with input. Now, as we saw earlier, we have this input event already here. Let's expand it a little bit. And we're going to handle a couple more input types, basically hitting the left and right arrow key. So event.type equals SF event type key pressed. So there's key pressed and key released. I'm sure you can guess what the difference between the two is. So if this is a key pressed event, we are going to check for specific keys, basically the left arrow or the right arrow. So now that we know that the type of event is a key, we know that event.key is set, and we're going to check the key code. Now the thing is, key codes are different on every platform, so don't just check for a number here. Use the built-in SFML classes, and that is SF keyboard left. So, and what we're going to do is move our sprite relative to its current position, which is to say sprite.move, and we'll move it 1 pixel to the left each time you press the left key. And now through the power of cut and paste coding, we shall handle the right key. And done. So now let's go ahead and run that. And I press my arrow keys, and now our image will move when we press or hold, like so. So that is event-driven input. When an event is received for a keyboard event, we can handle it this way. You can also directly poll events, and poll input. You can poll the status of the keyboard, the mouse, etc. And when you do this, it works pretty much exactly the same. It's just the layout of your code is just going to be different. Now be careful you don't handle the input of the event for a specific thing and then poll it, because you could end up double processing, right? So if you poll for left key and handle the event for left key and then apply logic on both, you could end up doing twice as much than you intended to do. But polling is quite simple, and we're just going to, first off, we're going to poll to see if the space key is down, and if it is, we're going to set the position of our image to the location of the mouse cursor. So first off, is SF keyboard is key pressed, so that's how you can poll. There's similar functionality for all the other input devices, and we're going to just check for SF keyboard :space. So is the space key pressed? And if it is, we go ahead and set the sprite.set position like so, and types are slightly different, so we're going to do a static cast here, SF vector2f, and close and open, and we want to get SF mouse. So now we're pulling the mouse like we did the keyboard, same basic logic. Now in this case, we can just go ahead and call that the day, all right? And this logic isn't going to work as you expected it to. First off, why am I getting an error? All right, the cast is closed, and yeah, I missed a close. Okay. The catch is going to be here. This is going to get the mouse's position relative to the screen. So if I'm here, it's going to be minus whatever it is to the top left corner of our window. So what you want to do is you want to pass in the render window, and this will confine the mouse position relative to just the window you're in, as opposed to the screen itself, the entire screen. And now let's go ahead and run that. And once again, you'll see left and right do so. And if I press space, then we move relative to our mouse position. That's it. That is handling keyboard, mouse events. Joysticks work the same. Pretty much all of them work the same. And the nice thing, again, with that transformable and drawable as base classes, the logic and code for dealing with the draw, etc., is exactly the same. Set position, load from file. They're all very, oh, sorry, that's a different thing. But they're all very, very consistent and clean in their approach. Now let's expand this one more time to make it something slightly more sophisticated demo. Nothing too extravagant. I don't have a lot of time left. But come on in here. We're in our root directory. I'm going to go ahead and create 2 new files. And what we're going to do now is load up a very old school GL shader. Let me see, call it shader, and we got 2 parts, .vert, so a vertex shader, and shader or a fragment shader. One is basically for handling the positioning of your vertices in space. The other one is for dealing with the color of each individual rendered pixel. Now, vertex and fragment shaders are way beyond what I'm going to cover here. There's a good link. If you go to the actual text version of this, there's a good link to resources on dealing with shaders. But this one, I'm going to just blitz through this. So that's organized slightly. Add new filter. We shall dub the shaders. And we shall add an existing item. And let's add our two new shaders, which are both text files, and our fragment shader. I'll copy and paste this sucker, is this. Our vertex shader is this. This is this really doesn't matter for the most part, but basically this is just positioning in space. This is a very stock standard shader. And then this is determining the color. And what we're doing here is we're taking each individual pixel as taken from the texture passed in, and we are multiplying it by the opacity that we're also passing in. And we're going to show you how to pass in, see these two uniforms? Think of these as external variables, and we're going to set these in C++ code. And what this shader basically plans to do is, it draws our pixels on screen, which is what this is responsible for, but it also sets the opacity based off what we're sending in. Now, there are much better ways to set the opacity than this particular version, but I wanted to show you a very simple shader in effect. So now we're going to modify. We're going to build on top of this existing example, but let's modify it slightly. And first off, we need to go ahead and create our shader. So SF shader, like so. And then, hey, but you can guess, if bang shader.load from file. Now, the only difference here is you can actually pass in both the fragment and vertex shaders in the same call. So vertex first. So shader.vert, and then shader.frag. Like so. Now, the kicker here is this is doing a lot more than just loading it. This is actually compiling it, etc. So not only does it have to exist, it has to be a valid shader too. So let's go ahead and run this. Make sure I didn't do any, well, I didn't type it, so that's why I copied and pasted. But if there are any errors in your shader, it will also blow up at this point. So this isn't just file not found type errors. If your shader doesn't compile right in the shader class, you will blow up here. There are much better tools for working in shaders too than in Visual Studio. Well, it's actually got nice support for HLSL shaders or DirectX shaders, but that's not of any use to you when dealing with OpenGL. So anyways, as I said earlier, float opacity. Start off with fully opaque, like so. And this is the value that we're going to ultimately pass in. And now we're going to go and set the two variables that are passed into our shader right here. See, we got this texture and the opacity. And the texture can be passed in using a special value. They're both done the same way. Set parameter, and you send in the name. So the first one is called texture, and then, as I said, SF shader current texture. So it's a special value SFML provides. So this binds it to the texture you're using, and the next one sets in, and we will set this texture shortly. You'll see how this is set in a second. We'll pass in the opacity value, that float that we used, like so, and so. So this binds these variables from C++ to the shader underneath. And now what we want to do is our shader is going to, well, I can show you it in action right away. So let me just change this down so that it actually does something. We'll give it a 50% opacity or 50% transparency if you're a half full or half empty kind of guy. And we just pass in the shader along with the sprite. This is what binds the texture to the shader. And so right here, let's go ahead and run this code. Hey, why are you not happy? Oh, I always do this. Sorry, pass in a reference to said shader, like so. And boom, there is our image drawn at 50% capacity or 50% opacity. So there is the shader being applied to the image. And obviously we could even apply that shader to that font we used earlier if we wished. So you could reuse the same shader. The shader can be a hell of a lot more complicated than what we've done here. Now the there's a couple things to be aware of. Actually, you know what? Let me finish this example, and I'll come back and talk about the perils of using shaders here. First off, now let's add up a little bit more logic. So we want to have it over time that shader is. So we start with fully opaque. And then over time, we're going to decrease the transparency until it's invisible, and then we'll go back to opaque again. So what we need to do is handle transition of time. And there are methods built into SFML for handling this. There's a time class, and there's also a clock class. And a clock can be thought of as a timer. A very simple class. The second you created that, it basically starts counting. And there's only two methods in there. One is to get the time, and the second one is to restart the clock. That's it. So it makes a very handy, easy timer. So there is our clock. And as I said, when it's created, it starts. So now, after our logic for handling input, let's go ahead and handle our clock. If clock.get elapsed time as seconds, like so, is greater than 1/10 of a second. So every 1/10 of a second, we shall update, and what we will do is change our opacity down by 5%. If opacity is less than 0, opacity equals 1. And then finally, after all of that, we want to restart our clock and pass that new opacity value into our shader. I can't type opacity and then opacity, like so, and run. Oh, I did something very wrong. Oh, I know what I did. I missed a 0. That's 50%. Let's try 5% instead. And that's much more gradual. So that is binding a shader to a drawable object in SFML. As you saw, the code hasn't changed a lot. The approach that we're taking is not changing a lot. None of this is really difficult. There's not a lot of weird black magic going. I haven't created a pointer yet. I've had a single reference. Memory management is handled all on these objects going out of scope, taking care of themselves. So there's not a lot of complicated memory management here. The approach is clean. The library is clean. Everything is very clean and consistent. So when you're working with SFML, if what you saw here today looked clean to you, when you deal with music, when you deal with networking, when you deal with various other kinds of input, etc., what you just saw is what you get. It stays the same. So there's a very nice, consistent cleanness to. I'm going to turn this off before it gives me a stroke. Very nice, clean consistency to SFML. So if what you saw right now looked appealing to you, this library will be appealing to you. Now, quickly back to shaders for a second. One of the big challenges here, and something I didn't touch, I actually completely forgot to mention, is the platforms that SFML runs on. And up until 2.2, SFML has been a desktop-only library. It runs on most Unix environments, Windows, Mac OS. However, as of 2.2, there's been experimental support for iOS and Android. This is a big development. This is probably one of the biggest things recently anyways that's been holding back SFML for usage, in my opinion. So now there is support in there for these two mobile platforms. However, at least right now, they're working on OpenGL ES1. And that is a very antiquated, very old, very outdated version of OpenGL. And what that also means is there's no shader support. So you can't use shaders with the mobile targets yet. Now, a lot of the times you're not going to need to use shaders. They're a very handy way to do a lot of things, a lot of special effects. If you go to a place like Shader Toy, you can see the power of vertex and fragment shaders. And there's the other thing, is it's vertex and fragment shaders only. So there's no support for tessellation shaders, geometry shaders, etc., some of the newer stuff. It's just for vertex and fragment, unfortunately. But it being a 2D only library, that isn't a huge handicap. Now, before I close up, let's talk a little bit quickly about the community, etc. Now, SFML has been around for quite a while. I think it's probably at least 7 years, 8 years type thing. Again, it's fully open source, zlib license, GitHub hosted. There is a very active community. It is at, where's my web browser? Let's bring that over. Here's where I cut my paste my fragment shaders from. Here's the Here's the text version of this post, by the way. But if we go over here to SFML development, this is the main hub and home. And there is a community, an active forum right here. It's available in English and in French. It's not the biggest community by far. There are definitely other communities that are bigger, but it is quite large. There are a lot of people using SFML, but the amount of people answering questions is quite a bit smaller. But they are pretty good about solving and answering questions. They can be a little hostile at times. Now, granted, this is a C++ world. There's a lot of people that basically come in and go, I want to develop games in C++. Well, if you don't know C++, you're going to run into things like the linker crap that we saw earlier on. So it's easy to get frustrated at these people. But in all honesty, on the forums, it's probably 20 or 30 people answering the vast majority of questions. And they can be a little short at times with their answer, but they are very good about answering. So if you are looking for help, it's out there. And there's ages and ages of post history here to go through. So if you search for something, there's a pretty good chance that you're going to find an answer. Now, another challenge that presents, however, is at 1.6, SFML was re-architected. A lot of it was to pick. You remember when I saw earlier things like getSize.x, where it should be width or height, etc. They went and they fixed a bunch of stuff like that. Especially there was a very inconsistent set of naming conventions earlier on, and they re-architected it to be more modern, more consistent across the board. But this broke a lot of old examples. So when you do search, make sure that your result was in the last 2 or 3 years to make it sure it's most accurate. Now I have a tutorial series here on GameFromScratch.com from years ago that covers SFML game development, and even since the re-architecting, the code is still, for the most part, followable. So it's not a huge break, but just be aware that older code may not be accurate to what it is now because of this reorg that happened at version 2. Version 2 and on code should be, for the most part, good to work with. Another challenge is they used to release very, very slowly. Fortunately, this seems to have sped up quite a bit, so that's nice. This means bug fixes are getting out there faster. And that was probably my biggest beef with SFML in the 1.6 and 2.0 era. So there were existing bugs for a year to 2 years, and that if you can't build from source is a huge deal breaker. So fortunately they're now starting to release things a lot at a lot faster pace, and that works out in the advantage of everybody. So that's the community, and if for some reason SFML's forum community doesn't work for you, it isn't well embraced in the indie community. So if you go to a place like GameDev.net, TIG source, there's even a complete SFML Reddit on, well, Reddit. So our GameDev or our SFML, there are a lot of places to have your questions answered. The same way as Stack Overflow has a fair number of SFML questions available too. So there is good support within the community. So that's a very nice thing about this engine. Definitely something to watch for. On top of that, there is the help materials available. Now there are 2 sets of help here. One is, and let me just go back to the web page. We'll go to Learn. You got a set of tutorials, and you've got a set of the API reference. And then the nice thing is the community also has a series of books available. I've also linked them on GameFromScratch.com. Now your tutorials is a lot of what I just showed, to be honest, using things individually. They're pretty good. They're community provided. They can run the gamut, so there's ones on getting you set up and going. I have found on occasion glaring holes or missing gaps in them. So if you're just starting out and you're like, did we just miss a step? Well, that happens on occasion in the tutorials, but for the most part, they're quite good, and they cover most aspects of working with SFML. Next, you get on to the reference materials, which were right here. These are, without a doubt, exceptional. The reference material is some of the best I have seen, basically since the old days of Microsoft MSDN, before they decided to start sucking more. Microsoft used to provide, by far and away, the best developer reference material you've ever seen. When you're dealing with SFML, which has a very defined function, what it does is very clear, and then how it does it is also very clear thanks to this reference material. It's broken down by module or class. So basically you could get it based off the lib file that you're working from, or an entire class hierarchy here. And let's use an example. We'll go with the text that we saw earlier on, so I can show you some of that inheritance graph too. So we bring up the text classes here. You'll see it shows the class inheritance. You can easily jump back to the parent classes. There's good, solid documentation. We scroll down here. There's guts to it. Everything you need to know is there and documented. There's often code samples here. Every method is documented. All of the parameters are documented. It's not a, a lot of times with an open source project, you'll come in here and you'll see blank or to do, or basically the documentation is git rotation, and then it will be git rotation. And it's the little things like this key line right here basically says that it's from 0 to 360, whereas in another one you might go, well, shit, is this in radians or is this in... Well, the nice thing is this documentation has the information you need. So here's one thing I have to say right up front. Kudos to SFML team. You guys bang out nailed it on the documentation. And if you're an intermediate to advanced level developer, you will not need anything more than the documentation, to be honest. The library is intuitive enough. You're not going to be sitting there going, oh, how do I do this, how to do that often. Now, our closing, we're going to get into one last area. This is what it doesn't do. SFML is a very defined library. It handles, input, graphics, cross-platform specific things. Like the nice thing is in system there are advanced classes I never touched on, things like for threading, mutexing, UTF support, etc. So things that are complicated to handle in a cross-platform manner, SFML provides a nice abstracted interface to doing those things. But that's it. There are, however, libraries built on top of SFML. There's the Thor libraries, which basically is just an extension of SFML. Adds things like advanced math classes, I think tweening, animation support, etc. So a lot of functionality is added using this Thor library. There's another library for playing movies. There's a couple other, and of course, being a C library, you could easily slot in box for physics, etc. There's a library for loading TMX files. So even though there's no level editor here, you could easily use tile editor or map editor and implement TMX files and then load them using SFML. So there's a good chunk of example code to work from. There's extension libraries out there. So while SFML is not a game engine, it and its community can easily make it into one. So that's it. That's basically what I wanted to cover. Hope you found that interesting. Once again, there is a text version on GameFromScratch.com. Be sure to check it out. You can get all of the code we just wrote here available there as well. Hope you enjoyed that. Thank you very much. Goodbye.